Hello, this is Scott at Aquascape ATX. Today I thought I would go over some slides I've put together on aquaponics plumbing. I've made a lot of mistakes over the years myself and found some things, some best practices that I think would benefit others if they're designing a system. So without further ado, let's jump into the slides here. So a well-designed system is stable and effortless and easy to maintain, which mine, I think I'm about to that now. And a poorly designed system will cause you a lot of headaches and frustration with water losses and clogs, and can make the whole aquaponics experience very frustrating. So I've used this slide several times in the past. That's a nice slide to talk to. Here's your fish tank with the bottom drain. So this can either be a drain in the bottom of the tank or a pipe that's stuck down with a little gap between the bottom and the pipe. Siphon break is very important, so you don't, if you ever end up with some issue downstream here, you're not totally draining the fish tank. That should be in this fairly large pipe. It goes into a radial flow filter where most of the solids are separated out. Then the mostly clean water goes into the sump. And then from there, you have a pump that will pump it into the beds and back into the fish tank. And then there's siphon valves here that control the water flow from the bed back into the sump. So that's the big picture. So kind of keep this in mind. I might talk about it on future slides. Design parameters we're going to want to think about as piping and the resistance to water flow. So typically pumps in submersible pumps have a high flow rate but a low head pressure, which means anything like a narrow pipe will quickly cut the flow rate of water through your system. Aquaponics water has a lot of material in it, from fish waste to leaves and other debris. So all the plumbing is very prone to clogging. Good news is you can design around this and eliminate most of these problems, but you can also get into trouble pretty quick if you're not thinking about it, which leads into solid waste removal. Very important concept that we'll talk more in, but you want to have several setups in your system that are removing solid waste and keeping it out of your plumbing system. Energy consumption, good news is most of your pumps and aerators and things do not really take that much power. I think one circuit would probably be fine for your plumbing system as long as you don't have any voltage, high power heaters, electric heaters, which I would not recommend because it takes a lot of power to make any difference. Aeration, both passive and active are important things to incorporate. Of course, cost is always a factor, or almost always a factor. You can do things fairly inexpensively, but you're going to spend a lot of money if you want to. Complexity typically is not your friend. You want to architect your system with a minimum amount of complexity so that it just stays clean on its own. Manual filtering, like cartridge filters, can be beneficial in polishing your water, but since you have a high solid load, typically they will clog up pretty fast, and you're going to spend a lot of time washing filters. And so you need to be thinking primary filtration coming from things like radial flow filters. And anything you're designing, you need to think about, how am I going to maintain this? What if something fails? How do I work on it? And what's going to be my daily or weekly workload to keep the system clean and nice looking? Which leads in, your primary maintenance thing to be thinking about is solid waste removal. So fish continuously generate waste. The good news on that is that you do have some control over it. You have a lot of control over it. First big things being number of fish you put in your system, the stocking density, and then the other thing is how much you feed them. You can greatly vary the amount of waste being generated just by how much you feed them. And fish, they can go a week without having food, so not most people err towards the side of feeding them too much. Of course, the more you feed them, the faster they grow, as long as all the other needs are met. But fish generate waste, and the solid waste will quickly overload your garden beds if you're not careful. If you have too high a fish density or you don't have enough filtering to remove it from the beds, they'll get nasty and stinky pretty quick. So if you're doing a bed-only filtering, you're not putting any radial flow filters or other filtering mechanisms, then you need to really drastically reduce your fish density so that you don't overload the beds. On small systems, your sump and your fish tank are typically one and the same. But if you're making a bigger system, one of the first things is nice to break apart your sump from your fish tank so that you can filter the solid waste before it gets into the sump and then out to the beds. And one of the most powerful ways to filter out solid waste are radial flow filters. And I have a slide to actually talk to this, but you need to be, if at all possible, design a radial flow filter in your system. And don't rely on cartridge filters or manual filters for your primary filtration, or that's going to be a constant headache. They clog up really fast. Clog prevention. The good news is you can design your system to avoid clogs and virtually eliminate them. On top of that, though, don't let leaves or other matter accumulate in the sump. Scoop them out. Don't overstock your system. The more fish you put in, the more waste is generated and the more waste you have to deal with. Don't overfeed. Your fish food should be consumed in a minute or two. Don't definitely not over. If it's sitting around there for 10 minutes. If it is, then you need to adjust the amount of feed going in, and monitor your water profiles and make sure you're staying in the recommended ranges for ammonia and nitrates and nitrites and phosphorus. Are the big ones that can get you in trouble on growing algae. And then there's other ones that are definitely iron and potassium that you need to be looking at just for plant health. And when you do get into a clog, typically you can shut off your pump and then hook a hose up to the output tube of where it's going into a bed or back in the tank, and just push water backwards through it, and that'll typically break loose clogs that are in plumbing. So not the end of the world if you get a clog. Usually you can recover from them pretty quick. Water flow is paramount in aquaponics because you're moving water around. That's how you transfer the nutrients from the fish tank to the plants and have the plants clean the water for the fish. So knowing that, aquaponics water has solids in it. So one trick you can play on this is always use larger pipes and high flow rate to reduce friction and prevent clogs from happening. Don't regulate water flow with a partially controlled valve. It's a recipe for disaster. It will clog up, guaranteed. Done it and fought it, and finally remove those from the system, and all those problems went away. Avoid any neck downs, going from a 1-inch pump down to a 3/4 inch pump, wherever you do, or 1-inch pipe down to a 3/4 inch pipe or a 1/2-inch pipe. Plan on, if you do that's probably going to be a place where solids accumulate and you're going to be cleaning it. High flow rates are always your friend. I tend to oversize my pumps and then turn them on and off, and that surging when it comes on tends to blow through a lot of clogs and dislodges material that is collecting in a pipe, versus a pump that's always on a slow flow rate. The pipes will tend to clog up. Avoid any dips or dead spots. Avoid any sharp corners. You typically do not want to use you can get away with using normal T's and elbows, but they will slow down flow, create turbulence, and is a potential place for clogs to happen. Best to use your pipe to make your bends and corners, and you have one straight run of pipe from your pump to the output where it's dumping into a bed. And then waterfalls and streams are always good passive aeration to incorporate into a system. And they're kind of nice for visual and audible. Hearing the water flow is nice too. And it's a nice safety valve to make sure there's at least some air going into your water for your fish. Types of pipe. So firstly, copper, iron, galvanized. Do not use it. Don't do it. Stainless steel, you can use it, but it's super expensive and there's really no need. You can go to rigid PVC. This is the stuff you see in your sprinkler systems in your yard. Very low cost. Does have some temperature sensitivity. If you freeze water in a PVC pipe, it's going to crack. Not probably, it will crack. The fittings will reduce flow rate. The pipe is UV sensitive. It will break down over 5-6 years and gradually lose its strength and eventually crack and crumble. But I have used a lot of rigid PVC, especially underground in my system, and it works well. I wish I had gone to larger pipe sizes than I did. And that would have solved a lot of my problems. So not a bad solution. The other one to look at is what I'm not really excited about is Flex. I've used some of this. It's cheap. It's flimsy, but you can get a high flow rate because you can get 1.5 inch flex pipe is very cost effective. Problem is it does not tolerate pressure at all and will start generating pinhole leaks pretty quick. And it seems like every fitting I've done in a flex PVC seems to leak. PEX-B, commonly used by DIYers, which is it's not a bad solution. It is cheap, easy to work with. Crimps are pretty straightforward to do. Good temperature tolerance. It is UV sensitive, so you're going to have to paint it or cover it or shield it, sleeve it. And the real downside with PEX-B is the fittings, the crimp fittings. Every fitting that's inside a PEX-B pipe, it reduces the flow rate, which becomes a neck down, a place to cause clogs, and it pretty quickly will reduce the flow rate of any water going through a system anytime you go through a PEX-B fitting. If you're going to PEX, I would really go to PEX-A. The fittings can be a little more expensive, but the ID of the fitting is the same as the ID of pipe. It's just the way PEX-A is designed, so it generates has a much better water flow. There's fewer restrictions. And the tools are not that hard to use, really. It's I've played with them and used to put a little expansion fitting on the edge of your pipe, open it up with the tool, you do X number, 5 or 6 squeezes of the tool and expand it out and you screw it on your fitting. And then the PEX tubing has a memory effect in it that shrinks back down onto the fitting and makes it really high quality. PEX-A is what all the plumbers use, for a good reason. Just don't forget the expansion fitting on top of the pipe. It sits on top of this pipe here. Radial flow filters are anything but the smallest system. I would incorporate a radial flow filter. And I talked briefly on on one of the intro slides, but you want a large 1.5 inch or even 2 inch pipe that's coming out of your fish tank into the filter. And no pump. This should be gravity fed, and the inlet should be sucking from the bottom of the tank with, of course, a siphon relief on it. And so the water with the waste in it flows in, the waste settles out, and the mostly clean water comes out the other end. This picture shows a conical tank, which with a valve on the bottom, which this certainly will work pretty good for because the sludge will collect in that cone. These tanks can be a little more expensive. If you can do it with just a plastic barrel, those are pretty easy to come by. A lot of times they're free or virtually free. You're really just paying for shipping to get it to your location. But when using a plastic barrel, you've got a big flat area in the bottom that the slime, the sludge just spreads out across. So putting a valve on the side here is not going to help you too much on pulling all it out. So what I've gone to is I just take a submersible pump, set it face down here in the bottom, plug it in, and then dump that output from the pump into a couple buckets, and I'll move the pump around, just to kind of face, wherever the sludge, and that seems to clean it out pretty quick. So, any type of, unless the very smallest system, you're going to want a radial flow filter in your system coming out of the fish tank. Standard DE filters I've not played with. Certainly they work very well in pools. But you do have a much higher biological load in a aquaponics, so it will it's going to clog up your medium pretty quick, and you're going to be doing a lot of back flushing. If you use DE in your filter, make sure you're going to pump a sump first before it goes into the water goes back into the fish tanks, because the DE powder will irritate the gills of the fish. And your backwash, the good news is the backwash from out of your filter can be routed to fruit trees or trees in your yard that can use the water and the fertilizer. And it's a great supplemental fertilizer for anything else in your garden or your yard that any trees and things like that will like it. Cartridge filters. I've played with these. I don't really like it. You need a pump, to drive the water through it. So right there, you've emulsified any of the waste before it even hits the filter cartridge. Which typically the filter will catch it, but you are generating a lot of small particles. If you're going to put one in, I would definitely have a radial flow filter in front of it, and then put the cartridge filter in series with the outlet of the pump, but knowing that you're probably going to be fighting those filters clogging up, and it's going to reduce your flow rate pretty quick, so you're going to stay on top of it. I think you can do a system without a cartridge filter. You can keep your water clean, but it is something to consider. But I think my experience so far is I don't think they're worth messing with. And you can keep your water clean enough just by using a radial flow filter. Siphon valve. So this is the mechanism that's used for a flood and drain system to regulate the water level in the tank. And so this area over here, you could vision the tank with a median of clay balls or gravel. As water's pumped in, it fills up to the point that it gets where this the siphon tube is. This here is typically like a water bottle or a 2-inch piece of pipe, and the siphon tube is a 3/4, and this is open on the bottom. So as the bed fills up, this gradually floats up to the point that the water starts flowing out the tube, and then it starts gushing out into the tank below. And this is a 4-inch pipe with holes in it around it that keeps the median out of the valve area. Very important that you have a air gap coming out of here. Typically, this will be just a straight down, or a lot of people put a 90 just to direct the water to generate some currents and better aeration in the tank below. But you don't have to have this 90. But don't add any piping downstream of this. You definitely need to have an air gap here, otherwise it won't break the siphon when the water gets low in this bed. But there's a lot of videos you can search on siphon valves, aquaponics siphon valves. A lot of good videos on how to build them. This 4-inch tube is perforated and has a cap on the bottom, and typically you use a 3-hole fitting through this cap and a gasket to seal it to the tank. I say not a lot of good info on it. Certainly reach out to me if you need help with one too. Pumps. Anything any solid waste you put through a pump is going to emulsify it and dissolve it into the water, just make it harder to filter downstream. So it's best to gravity feed things like a radial flow filter before you pump your water. Pump, you want to size it properly so that your beds see about 1 change per hour. So you just look at, calculate out the volume of your bed And don't worry about the media that's in there. Just do for the total volume. Though the media is probably knocking out 40%, 50% of the volume. But just look at your bed size, calculate the volume, and figure out your flow rate. That will swap it out once an hour. I like to upsize the pump and then turn it on and off. So if you double the size of the bed, then shut it off on for 30 minutes, off for 30 minutes, and that keeps your pipes a lot cleaner, keeps the systems less susceptible to clog. So I like doing the duty cycle. Of course, that can be 2 beds, 4 beds, 6 beds, and just do your math accordingly. Typically, I've always used submersible pumps. They're quiet, they're cheap, they have a high flow rate, so you're moving a lot of water around. Works pretty good. Downside is they have low head pressure, so you need to use large pipes. If you neck it down to a small pipe, it's going to reduce your output pretty quick. And I think I use Alpine pumps, nothing special. They seem fairly reliable. They all have fairly common outputs, so I keep a couple extra around in case I have issues with one. I can just swap them out. You can use centrifugal pumps, but they are noisier. They since the pump's outside the tank, you have potential for leaks on any of those fittings. You can get self-priming type. That's typically what you see for a pool pump with a basket, and so you can eliminate some trash there. I think they can be a little harder to clean. The submersible pumps are nice because they just unplug it, pull it out of the water, take the fitting, the output hose off, and then you can hose it out, clean anything that's accumulated in it, and then you screw the hose back on, put it back in there, and away you go. And I have some pumps I think I probably maybe clean once a year, and there's some others that maybe once a quarter. So the submersible pumps are, I think, a pretty good solution. Valves. You're going to definitely want to put valves on different things. A thing you want to avoid is partially closed valves, and don't regulate your water flow with a valve. You're going to cause issues. I like using motor control valves because I can put them on timers and turn them on and off, and so you can get higher flow rate. Or really you're going to need the valves and the timer if you have you're trying to drive multiple beds, so you can direct it to your output to different beds. You want to use stainless steel, no copper or brass. I like using 24 volt because it's a little less shock hazard than dealing with 110. You want to avoid any partially closed ball valves to regulate water flow. Do not regulate water flow with a valve. It's going to clog. Do not use any solenoid valves. They have small orifices in them, and they will clog up. And don't use any copper or brass. And there's, like I said, there's lots of valve sources out there. You can spend a lot of money, or you can get cheaper, less reliable ones with plastic gears in them that will fail over time, but they're a lot smaller investment. And the path I've taken is I just buy 3 or 4 extra and swap them out when one fails. Controls, you can get really fancy here. You don't have to. You can use a mechanical timer that you see at any you can get in grocery stores, garden stores, or you can go to the little puck timers that plug in line with a power cord that you access with your phone, and those are on. You can get those, in any mail order place. Amazon has a ton of them that you control with Alexa or Google. And those are nice. You can just set it up to control. Those are nice for turning pumps on and off. So you can duty cycle them. I've actually added a PLC into my system, and the advantage of that is there's a whole ecosystem of valves and sensors that run on 24 volts that plug directly into a PLC. So you can pretty quickly do a lot of fancy things with a PLC. You have to keep it dry, out of the rain. They're not typically not waterproof. Or you can go with Arduino, other little microcontrollers. These are very cheap, but typically they are not at the right voltage to like a PLC, they don't handle 24-volt sensors and valves and controls directly, so you're going to do some interface circuitry, and they're typically more complicated to program. Though with the modern AI tools, that's you can have AI tool will typically generate, like Claude will do code for you that you can just download in and walk you through it. So that's not, and same with PLCs, you can have your AI tools that will generate your code for you. So it's much easier than it used to be. But I think for the vast majority of people, for a simple system, you have a pump with a that you're just duty cycling with one of these puck timers, and that'll kind of cover for 90% of applications would work just fine. Aerators, you definitely want to put some supplemental aeration into your system, especially as you get into higher stocking densities. When water warms up in the middle of summer, the fish will become oxygen stressed, so it's very important in summer to have a lot of aeration on. Fish like trout are very sensitive to oxygen levels. They require the most. Bass are not too bad, but you will, if you don't have enough oxygen, you'll see them swimming slowly, just drifting around the surface, and that's a sign that they're in oxygen stress, and you need to add more aeration. Tilapia and goldfish will tolerate about anything, though they definitely will be healthier and more disease-free if you have the proper oxygen level for them. I would not mess around with compressors. If you're going to do that, you need to make sure you probably want a refrigeration drying and multi-stage filters to make sure you're not getting any oil into the water. And you can use the self-lubricating compressors, but those don't seem to last very long to me when I've played with them. There's something you're going to be replacing fairly regularly. And you can get pond aerators that are, any of your pond supply store, the stores that do the pondscapes, or even your Home Depots of the world, or you can buy them online. A decent sized pond aerator, not that expensive, and just buy multiple of them. So if when one dies, it doesn't take down your whole fish tank, and just keep one or two spares. And when one quits, swap it out, put in another one. It's a low power, quiet, and very reliable, straightforward way to do it. Plumbing maintenance, the big things you want to just stay on. If you stay on top of it, keep the leaves out. Keep your radial flow filter clean. So you're netting out leaves or other things that fall in the pool. If you have manual filters, cartridge filters, you're rinsing those off and keeping them running. If you have a radial flow filter, you need to pump or drain that sludge out, and you will notice pretty quickly when you don't do it, or after you do it, how much the water clears up. It's kind of amazing to me when that happens. And then just watch for leaves or other debris that might accumulate in a place like a stream bed that would cause water to overflow out of your system. And in your design, you want to keep your plumbing as much as possible accessible. Either put it in a trench, a covered trench, or just in the open. But if you're in the open, you need to make sure you're protecting from freeze. And the bigger one is probably UV damage. As long as the water is moving, your pumps are on in the system, nothing's going to freeze up. Even if it turns on and off, half the time, it's still the plumbing's not going to freeze up as long as your ponds don't freeze up. The bigger thing on plumbing is UV that you're going to be worried about. And I think that is about all of it. If you like the content, please click the like button and subscribe. That helps my metrics. And if you have any questions, you can add something in the comments there. And I will have the slides, a link to the slides in the description. So I think that's about it for today. Have a good day and happy gardening.